I want to illustrate the regression anatomy with a demand simulation from before. So prices again depend on whether sunny or not, and the demand function also depends on it. And if we estimate the multiple linear regression where we add S as a control variable, we get basically consistent estimators. Now in the regression anatomy, we would first run a regression, which I save as reg1, of the explanatory variable we are interested in, so that would be the price, on all the other explanatory variables, so that's only S in this example. I run this, so basically that's the following estimation. P is equal to alpha 0 plus alpha 1 times S plus some error term, which I call eta here. And now we want to get the residuals of this first regression. And we call this residuals we could call them eta hat, but I also call them P tilde. So they are the residuals from reg 1. And you could think of the residuals as that variation in the price that is not explained by the weather condition. So in our simulation, it's essentially this random term that does not depend on whether it's sunny or not. That's essentially the residuals from this first regression. Now it's everything that makes the price vary, but does not depend on the weather. And we know that this residual now is uncorrelated basically with U. So and also the residual is uncorrelated with S. So what I do now in the second regression, I regress the original dependent variable Q on this P tilde. And now I get a consistent estimate for the coefficient in the price. Intuitively, I only use the variation in the price that's uncorrelated basically with the epsilon in the short regression. In the short regression, the epsilon would be beta 2S plus U, but we know that P tilde is uncorrelated with S, so it is, and also uncorrelated with U, so it's essentially exogenous now in the short regression, and therefore we get a consistent estimator. And indeed, here the estimator is, let's write it down, minus 1.0139. And if we look at the multiple linear regression that's run here, we find exactly the same estimator. So the estimate is exactly the same if I do this regression anatomy or the multiple regression, only the standard errors differ. They are correct basically in this multiple regression. So it basically means these two approaches are equivalent. But that means if I really formally want to check all conditions, whether our estimator beta 1 is consistent in this multiple regression, we can basically apply all these conditions for this second stage regression of the regression anatomy. That's kind of helpful.